The popularity of diving has put a great deal of stress on our underwater resources. One way to deal with this has been to create marine sanctuaries or no-take zones where all marine life is protected. If you saw our 2 Cuba episodes, they took place in the Garden of the Queens Marine Preserve.
While this has helped, there are other problems such as coral bleaching. The Coral Restoration Foundation, or CRF, was formed to take an active role in not just protecting, but actually restoring coral reefs in the Keys and other areas of the Caribbean.
Alex Neufeld works with CRF and is here to tell us all about their program.
I'm Alex Neufeld. I'm with the Coral Restoration Foundation, which is a 501c3 nonprofit marine conservation organization based in Key Largo, Florida. We've been actively restoring coral reefs since about 2007. And the way that we do that is by growing small fragments of endangered species of corals like staghorn and elkhorn in our offshore nurseries. And then once they reach a certain age and a certain size, we actually plant them back onto the reefs in the areas where they've seen the sharpest declines. We're trying to do this so that we can restore some of that lost genetic diversity and overall reef diversity. These corals are keystone species. They provide habitat for a lot of different fish and invertebrates that people down here in the Keys rely on for economic value, whether that be the fishing industry, the tourism industry. So we feel like what we're doing has a lot of very real applications to people's everyday lives down here. Here we have a model of one of the coral trees that we use in our nurseries. This is the structure that we actually grow corals on. And we have some dead coral skeletons here that we've painted to sort of model what this would look like in the nursery setting. So this tree is made out of a PVC pipe trunk with fiberglass rods that represent the tree branches. And each one of these branches can hold between 6 and 10 pieces of coral. So all told on a tree, that's between 60 and 100 fragments. These are staghorn corals. Right here we can also grow elkhorn coral in the same configuration. And we've also started using these tree structures to grow star corals as well. Now with the star corals, they're a little different because they're not a branching coral, they're a bouldering or a mounding coral. But we use plastic ID cards that the corals will actually grow onto. And then when they get large enough, we can remove them from the cards and plant them on the reef just like any other coral. This tree here has a base so that it can stand on land, but in the nursery, in the water, this tree would actually be anchored to a duckbill anchor that's driven into the sandy bottom and then floated with lines and styrofoam floats so that they are suspended in the water column and they can sway with the currents. This also helps protect the trees and the corals from major storm damage and also keeps them from being run over and destroyed by passing boats. When we plant the corals, we typically plant them in groups of 3 or 10 in a group called a cluster. And when we plant the corals, we want to give them enough space that they can grow individually for a little while, but keep them close enough that they eventually morph into a single large colony called a thicket. And these thickets are what actually provide that habitat and that structure for those reef fish, for those invertebrates. And it's the mature thicket that will actually spawn after 4 or 5 years on the reef. Spawning is a critical process for these corals because without spawning on the reefs, the corals would experience a genetic bottleneck and they would eventually die off. So it's really critical that we get these corals out on the reef, see them survive for 4, 5, 6 years, get them to the point where they can spawn and actually begin to replenish their own populations naturally. When we're in the nursery to actually collect the corals to be prepped to go out on the reef and be planted, we'll come to a tree like this and we'll look for pieces that are about this size or maybe a little bit larger, and we'll cut them down from their monofilament attachments. We'll then take the corals and organize them by genotype into milk crates, which are then taken up onto a boat and placed in tubs of fresh seawater. The boats can then travel to our outplanting sites, which are usually no more than 30 or 45 minutes away from a nursery, and they can then be placed right back into the water where they're ready to be planted.
That's really cool. And when we come back, we'll take you back underwater to show you what they're doing to map the coral. We get our hands dirty to help the CRF.
Manually surveying reefs where coral has been planted is a really time-consuming and laborious process. So Alex and David Gross are developing photomosaic technologies that will simplify this. The first step is to mark an area to be surveyed with weighted floats at the corners. Then Alex swims back and forth over this area with 3 GoPro cameras mounted on a pole, and they're taking continuous photos. One problem they encounter with their funding sponsors is answering the question, hey, this is great, but is it working? Does the coral you plant survive and flourish? It's a fair question, and with the program underway now for several years, it appears that it is working. But showing proof is critical. Once back in the lab, they then use a software program that stitches these images together into a single large map of the bottom, and that allows the entire restored reef area to be reviewed at one time. The concept is to repeat this periodically such that the growth of large areas can be accurately determined. When we come back, it's time for the clip of the week. Stay tuned.